I probably have a little bit more written down on this one than what I need here, but we'll go through it, all right? Part A just says, is G have a relative max, relative min, or neither at x equals 10? First of all, G is the integral of f, which means G prime is equal to f, G double prime is equal to f prime. Now at x equals 10, G prime is equal to f. So this is my G prime graph. Now G is going to have a relative max if G prime changes from positive to negative, which means f would change from positive to negative, which means this graph would go from above to below the x-axis. G would have a relative min where G prime equals f changes from negative to positive. That would be for this graph goes from below to above the x-axis. So like x equals -2 would be a relative min. X equals 6 would be a relative max. But at x equals 10, this graph doesn't change sign. F is negative here, F is negative here, and F is G prime. So that means G prime is negative here, G prime is negative here. If you made yourself an XYY prime chart and you had like x equals 10 down there and your derivative was equal to 0, to the left and to the right of it, you would have a negative and a negative. So your function stays decreasing, not a max or a min, because the derivative does not change sign. So I kind of jotted some stuff down for myself just to remind myself what makes something a max versus a min. But this neither at x equals 10, since that G prime equals f, does not change sign right there. Letter B says, does G have an inflection point at x equals 4? So there's x equals 4. Now, inflection point, here's where that justification helps me out. I know G has an inflection point where G double prime changes sign. And since G double prime is equal to f prime, that same thing is asking where does f prime change sign? But this is not the graph of f prime. So I'm not looking at where this goes from above to below or below to above. This is the graph of f. So to get from f to f prime, that's the derivative, that's the slope. And so I want to know where the slope of this f graph changes sign. Anytime you want to know where the slope of a graph changes sign, is where that graph changes direction from going uphill to downhill or downhill to uphill. And since that x equals, I'm sorry, I pointed x equals 4 right there. I shouldn't have done that a little bit ago. X equals 4 is right here at this point. So my bad on that. But notice how the graph goes from above. It goes from increasing to decreasing. So this graph changes direction at x equals 4. It goes from increasing to decreasing. So yes, G has an inflection point at x equals 4, since that G double prime, which is equivalent to f prime, changes sign. It goes from a positive slope to a negative slope, from increasing to decreasing right there. All right, now letter C wants me to find an absolute min and the absolute max on G in between -4 and 12. So remember, absolute max and min problems, you got to make an XY chart and you got to check the endpoints of your interval and any critical numbers there. So the critical numbers are where the derivative is equal to 0. Now it says on G, so I want to know where does G prime equal to 0 and G prime is equal to F. So F is equal to 0 where it crosses the x-axis, where it hits the x-axis. That's -2, 2, 6, and 10. So that's why I was kind of throwing all those numbers in there in addition to the endpoint. So I'm doing my 3.1 absolute extrema process, checking the endpoints of the interval, and then my critical numbers where that derivative is equal to 0. Now, technically, at x equals 2 and x equals 10, the derivative didn't change sign on either side of that. And so technically those are neither a max or a min. Now I did just throw those on the chart just because it asks for both things there. And if I have the whole chart, it's really going to help me out for letter D, because letter D, some people get tricked up on the first part of that right there. So I think it's helpful for letter D is if I have everything in that chart right there. Now, what you're trying to maximize or minimize is the G function, and G is the integral of the F graph in between 2 and X, right? So I'm just going to take -4, plug it in for that X right there. So I'm going to do the integral between 2 and -4. And remember, when it's not left to right like that, least to greatest, you flip it, make it from -4 to 2. But when you flip it, you got to switch the sign of your integral right there. And then, so then that's the area between -4 and 2. Now, in between -4 and 2, you have between -4 and 2, you're talking this triangle right here and then this triangle right here. And what I noticed on that, I noticed this triangle here was equivalent to this triangle here. So those would like cancel out, like a negative area and a positive area. So then really I just had to calculate the rest of this area. So I did 1/2 times 2 times 4. That's what gave me that 4 right there. But then that negative was there. So that answer was a -4. And then when you plug in a -2, you're integrating between 2 and -2, which means I got to flip them again, make it the opposite sign. And between -2 and a +2, that's just this one triangle right here, which is all above the x-axis. This is 1/2 times the base, which is 4, times the height, which is also 4. So that's half of 16, which is 8. And then that negative is there because I had to flip the numbers around. So I get a -8 for that. And then when you plug in 2 for that x, you're integrating between 2 and 2. So the integral of a point is just going to be 0, right? And then the same thing, or not the same thing, but when I go in between 6, when I do in between 2 and 6, right there, that's just the area of that triangle right there. So that's 1/2 times 4 times 4, which is going to give us 8 for that. And when I did the integral between 2 and 10, what I did, I started between 2 and 6. I said, okay, that was 8. And this is going to subtract out another 8. I'm sorry, so this was 8 here between 2 and 6. This is going to subtract out another 8 in between the 6 and the 10. And then you have this little extra sliver at the end of it. But just in between 2 and 10, you're just talking this triangle, this triangle. So I guess instead of doing areas, you could just notice that you got the same equal amount above and below. And then that's also going to be equal to 0. And then when you go in between 12 and -2 and 2 and 12, then you're just going to say, okay, between 2 and 10 was 0 because those canceled out. But then you're going to subtract out this other little guy here. So I did that area and I had to do a negative there because we're below the x-axis to get that -4 right there. So your lowest y value is a -8. Your highest y value is a +8. And you get your absolute max and mins that way. All right, now letter D says, where is your G graph less than or equal to 0? All right, so where is it equal to 0? Where is it smaller than 0? Where is it negative? Now, if you have this pretty extensive chart for letter C, it's kind of easy to see that here because notice that, hey, I got -4, -2, and then it goes up to 2, and then it has the negative values, and it hits 0, and then it's positive, and then it hits 0 again, and then it's going to negative values here. So if you look at your chart where it's negative, you're talking between -4 and that +2, and also starting between the 10 and that 12 right there. Now, you got to be careful looking at the graph. This 10 to 12 interval is pretty easy looking at the graph because your G is the integral from 2 to x, right? And so if you look at just the area between 2 to x, here it's positive because the graph is above the x-axis. Then when you go from 2 to 10, then it's 0 because that's where it's going to be equal amount above and below. And then when you go the integral between 2 and 12, see how the integral between 2 and 12, the majority of that graph is below the x-axis right there. And so that's why it doesn't start, because here, when you integrate between 2 and x, it's positive, 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 majority is above the x-axis. Then when you start going over here, then still the majority is above the x-axis, above the x-axis. Then when you hit 10, then it goes to 0. And then when you go beyond 10, more is below the x-axis. So that's why in between 10 and 12, that area is going to go negative. But so you got to be careful with that thinking because your integral, it doesn't start at 0 or the beginning of that graph. It starts at 2. And so if you can't really use that same thinking about whether the graph is above or below the x-axis because you're integrating from that 2 to the x. So for example, like when you remember when we did that 2 to the -4, 2 to the -2, when you plug in -4, -2 right there, you can't say, oh, but the integral between 2 and -2 is above the x-axis, so it's not going to be less than 0 because you're kind of going backwards, right? So, you know, when we plugged in that negative number, we had to reverse it, and then that made that sign different there. So I just think it's a little bit trickier and dangerous to think about the graph sometimes there like that. So I would just kind of look at your chart, see where you got those negative values at, and so then you could choose the -4 and 2 and 10, 12. You could even like plot a bunch of those points. So I think I did that down here because I was just trying to be overly cautious. I was plotting some points there. I said, okay, where is it negative now? That's in those intervals right there. Tractor.